Okay, we are live again. Welcome back for AP Computer Science A live lessons, and it is Wednesday of Array Week. So welcome back for those that are joining us for some information about arrays. My name is Rob Schulz. I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerland. I teach at Hoover High School in Hoover, Alabama. We're glad you're with us today. Here's our map for right now. We're always going to try to drop new pins as we have people joining us from different places. Welcome. We hope that you're glad that you are reviewing with us during this spring. First, we want to cover what came out last Friday about the exam for 2020. It will be 2 questions, and I'll try to speed it up. If you come every day, then you've heard this multiple times, but it's never too many times for you to hear what's going to happen this year. 2 questions. The first of them will either be an array question or an array list question. You'll have 25 minutes to answer that question, and then you will upload it. And then you will be presented with question 2, which will be either, well, it will be methods and control structures. And you'll have 15 minutes to respond to that question and upload it. And you can see that respectively, they're 65 and 35% of your exam score. The date of the exam is May the 15th, unless you have some issue, and you'll see the makeup day on the next slide. The time is synchronized globally, so you can look at your time zone. And we have some folks in India, and we think that's about 1:30 in the morning the next day for you. So place yourself there. And then there's a paragraph, sort of what I explained about the timing. And you'll be able to work in an IDE like JGrass, JDoodle, or on paper, or in a text editor, maybe something like Notepad++, even Google Docs, wherever you want to put your code. But you don't need to feel like you have a disadvantage if you don't have an IDE to work in. So that's that. The next slide talks about security, and we'll be reminding you of this throughout. You need to plan now to be doing your own work and to be prepared for this take-home test. And we're going to talk a little bit about that as time goes. But on Monday, which would have been I think the 6th was Monday, we had a homework assignment for you to read what College Board has put out about approaching a take-home open notes exam. So we'll be reminding you of that again, or you can look back at Monday's Powerup. And then you see at the bottom, the makeup day is June the 3rd, and the verbs. And I'm going to reference those verbs at the end of today again and give you the page number where they're from, because it's important that you start looking at those types of things. So today we are working on enhanced for loops and kind of progressing through arrays. Yesterday you looked at loops, different kinds of things to do with loops to automate arrays. Monday we learned about creating them, and then you can see that tomorrow and Friday we'll be spending 2 days on the last topic in Unit 6, which covers a variety of algorithms, 9 specifically, and of course you'll be able to add your own flavor to those. And now, Mr. Schulz.
Okay, yeah, I'm going to pick up from here. So if you were with us yesterday and you did last night's Power Up, go ahead and pull that out, and we're going to take a couple seconds and walk through. So this is from one of the past free response questions, and we had started it yesterday. In yesterday's lesson, we did part A. So if you haven't watched yesterday's lesson yet, you might want to go back and pick that one up before you watch this one. But we're going to finish up part B of the free response question. This is the trail elevation question. Okay, so just to kind of briefly review what this question's asking us to do. We are to write the trail method is difficult. So in yesterday's lesson, I shared the full description of the trail class. So this one says a trail is rated by counting the number of changes in elevation that are at least 30 meters, increasing or decreasing, between 2 consecutive markers. And then it goes on to say that a trail with 3 or more such changes is rated difficult. So they've given us a table, an example, that shows trail elevation data and the elevation changes between consecutive trail markers. And as you can see, it says that this trail is rated as difficult. In other words, our is difficult method would return true because it has 4 changes in elevation that are 30 meters or more. Okay, and notice also that includes both positive and negative changes, increasing or decreasing. So our goal is to complete the is difficult method. So let's take a quick look. The first thing that we need is we need a counter, because we're counting the number of times that that difference is greater than or equal to 30. So anytime we need a counter, we have to start by declaring an init and initializing our counter. So we're going to create a variable called counter and set it equal to 0. We've got a little if statement down at the very bottom that we're going to say if our counter ends up greater than or equal to 3, we're going to return true. Otherwise, we're going to return false. So that takes care of keeping track of the number of changes for us. The topic yesterday was traversing arrays. So we're going to need the code that lets us traverse an array. And if you remember our definition from yesterday, we said that array traversal is where I access all of the elements of an array between a starting point and an ending point for a specific purpose. So our for loop gives us our starting point and our ending point, and I'm going to explain in a second why it has to be markers.length -1. And then here's where we access the elements. Okay, so we're accessing the elements from 0 up to markers.length -1. And then the specific purpose we're looking for is if the absolute value of our difference between a marker and the marker that follows it is greater than or equal to 30, then we're going to add 1 to our counter. And notice this is where we take care of, I'm going to back up. Well, I can't really back up. This is where we take care of that issue where the difference might be, -30 or -45 or -50. We're going to take the absolute value of the difference, and that way we always get a value that's positive. So here's where we have to make sure that we're stopping at markers.length -1. When I do my comparison, I'm comparing the value at position I, and I'm finding the difference between that value and the value that's at position I plus 1. So if we took I all the way up to markers.length, then when we actually checked this one, when we check the value at position I, then the value at position I plus 1 would be out of bounds. So we'd end up with an index out of bounds exception. So knowing that we're going to look at I and I plus 1, we have to make sure that I stops short of the end so that we don't go out of bounds. Now, I think I mentioned yesterday, in the past, I would have shown the point values off of the scoring guidelines. This was from 2010, I believe. And in 2010, scoring worked a little bit different. We used half points and some different things like that. And I was worried that that might confuse things more than help, so I did not show points. But this is our solution for our is difficult method. So how did you do? If it wasn't quite where you wanted it to be, maybe go back and take a little time and take the code apart, put it back together. I tell my students that when they're working on lab assignments or when they're working on any assignment, really, whether it be a paper-based assignment or a lab assignment, the goal is to make sure that you can work through it line by line and explain what each line of code does. So if you didn't quite have the correct solution, go back and look at the solution I shared, or go out and look at the actual solution that was shared from the reading that year, and then walk through it one line at a time and see if you can specify or see if you can figure out or explain specifically what each line of code does. And if there's any line that you're not sure about, that would be a good one to touch base with your teacher and maybe share the code with them and say, hey, can you explain what line 12 does? Because I really don't understand what that one's telling me to do, or why logically it's set up that way. But if you can look through and you can explain every line, then you've got a pretty good understanding of what the algorithm does. Okay, so just a reminder, at the end of each review session, we are going to provide some information and some resources so that you can power up. Let's very quickly take a look at some review strategies as we start getting into what's to come today. Okay, remember we said that now that we're in review mode, we're cranking things up a notch. So make sure that you're staying with us as far as focusing the course concepts, making sure that you're following the concepts that we're talking about, and pay special attention to syntax. Okay, syntax is going to be something that's really important as we work forward. Even if you're planning on using an IDE for the exam, it's still a good skill to have, to be able to handwrite code and then go back and implement it and make sure that your code does what it's supposed to. And if you're like my students, you're going to get tired of hearing us say this, but you have to be taking notes. This is an open book, open note exam this year. So it would really, really benefit you if you have good, solid notes that you can go back and look at. And Mrs. Westerland has done an amazing job. We talked yesterday about the fact that her notes are pristine. She's such a great note taker. So use her notes as an example. Make sure that you go back and you're looking at her notes and not just using hers, but make sure that you're using your own notes and then supplement maybe with the notes that she's putting out there, or use them as an example. Okay. All right, let's move on to today's lesson. Today we are talking about the enhanced for loop. So some prior knowledge that would be helpful. We're going to be using for loops and enhanced for loops to look at arrays. So if at this point you're joining us for the first time, you've missed the lesson that we've done on array creation and access or array traversal, it might be a good idea to hit the pause button, go back and take a look at those first, because that's some prior knowledge that might answer some questions before you even get to the point that you need to ask them if you watch those first. Okay. What we're going to learn today is we're going to learn how to use an enhanced for loop for an array. And we're also going to talk in pretty in depth about what the difference is between a regular for loop and an enhanced for loop, because there's kind of a misconception that they're both for loops. They both do the same thing. In some cases, they do give you the same result. Some cases they don't. But even when they give you the same result, they give you the result by going a totally different direction to get there. Okay. And here's what I mean by that. Here's our first example. I'm going to slide my little video window up to the top corner here. I have two for loops. We have two arrays that are being declared with initializer lists. I have loop test 1 and I have loop test 2. Loop test 1 has some code that follows it that looks like what we've talked about with just our regular array traversal. I have a starting point. I have an ending point. I'm accessing the elements of the array between the starting point and ending point, and there's a specific purpose. I want to display what the value is of the elements that I look at. All right. Down here, I'm using what's called a for each loop. So if you've never seen a for each loop before, this is the syntax. And I want you to take a couple seconds and kind of absorb the differences. You know, up here we have an initialization statement. We have a terminating statement or a control statement. And we also have an increment statement. So we've got three different things going on inside the parentheses for a for loop. For a for each loop, I've only got two things. I'm declaring a variable, but I'm not assigning it a value, at least not that I can see. And I'm specifying the name of my array, or an array list if we were working with array lists. But in this case, we're using an array. So the syntax is a little different. Okay. Now, I will tell you that both of these loops produce the same result. Okay. They're both going to show us the contents of their respective arrays. But the point that we're going to make as we start working through this is that they produce the result in a totally different way. Okay. So here's what you need to know. Here's where we're going to kind of break these down a little bit. I want you to think about the for loop and specifically what it is that it's telling us to do. Okay. The for loop is telling us specifically that it wants us to display the element value at each index from a given starting index up to the given ending index. I'm giving it a starting point, I'm giving it an ending point, and I'm telling it to go to those specific locations as it works its way up the array and display the contents of the index position that I've given it. Okay. This is what the for each loop is telling us to do. The for each loop is saying for each integer that we're going to call value in loop test 2, display the value. All right. Now that doesn't look like much of a difference, but it's a very, very subtle. Actually, it's not even that subtle. There's a pretty big difference between those two statements. The first thing I want you to notice about the for loop, it uses index positions. So I can specify a location and tell it to go to a specific location and do something. I can give it a starting point. I can give it an ending point. You know, I could tell it that I want it to start at position 5 and end at position 15. I could tell it I want it to start at position 15 and work down to position 5 if I change my increment statement, so I decrease instead of increase. So I have some flexibility that I don't necessarily have with a for each loop, because a for each loop literally says for each integer value in loop test 2, display the value. I'm saying that I want you to give me everything from the start to the end, no exceptions, no No flexibility. I'm just saying I want everything from beginning to end, every single one, okay? I mean, literally, I want each integer, all right? So notice down here, I'm not using index positions. Now, again, you might be thinking, okay, that's not really that big of a deal, but here's where we start seeing the benefit of having index positions and no index positions. Because I'm referencing an index position, I can use a for loop, not a for each loop. I can use a for loop to access and to modify elements in an array. I can get an element, and then I can go back and I can change a specific element, all right? Because I don't access index positions, a for each loop can be used only to access the elements in the array. I can't go back and modify, and I'm gonna explain why, all right? So now I can practically hear your thoughts, coming from my screen. You're thinking, okay, well, if I'm limited and I can only access the elements in an array, why would I ever use a for each loop? Why not just use a for loop? Well, there's a benefit. There's some pros and cons, okay? The trade-off is because I'm using index positions for my for loop, now I have a risk of bounds errors. I can go out of bounds. I can reference an element that doesn't exist, okay? Or I should say I can attempt to reference an element that doesn't exist, all right? I can change my less than to less than or equal to, and I can throw an index out of bounds exception. The big benefit of a for each loop, there's no risk of going out of bounds because we're telling it we want each one. So it's going to know where to start. It's going to know where to stop. It's going to give us everything from the first one to the last one, no more, no less. Okay, so that's the trade-off. Okay, I can't modify things, but I know I'm never going to go out of bounds. All right. So for the code you're looking at where I'm accessing a value and I'm displaying it to the screen, as far as the result, there isn't a big difference. Now I want to take you back and I want to look at this. Let's say we modify our code so that instead of displaying each element, our goal is to go through and multiply each element by a factor of 5. Okay, so for my for loop, I'm taking the value at position I in loop test 1 and doing multiply equal 5. In my for each loop, I'm taking my int value and I'm going to multiply it. I'm going to use multiply equal 5 with that one. Okay, and again, the goal is to try and update our array. So I want you to take a look at the examples and kind of follow what's happening. Okay, let's look at our for loop first. First thing that happens is we use an initializer list to declare an integer array called loop test 1. All right, we hit our for loop, and the first thing we do is we declare a variable I, and we initialize it to 0. So anytime I'm tracing code with my students, I over on the side of the page where we're looking at the code, I make a little column where I keep track of my variables. So so I'm going to try and model for you in my PowerPoint what I would do if we were doing this on paper. Okay. Now 0 is less than loop test 1.length, which is 5. So we're going to go into the loop, and this next line tells us we're going to take the value at loop test I position 0 and multiply it by 5. So we're physically changing that value. We come back to the top of the loop. We increment our loop control variable to 1. 1 is still less than 5. So we're going to update the value of the element at position 1 by multiplying it by 5. And we're going to kind of continue through this. We get I equals 2. 2 is less than 5. So we go into the loop. We increment the value, or I should say we adjust the value at position 2 by 5 by a multiple of 5. We increment our loop control variable again. 3 is less than 5. So we come down into the loop. We adjust the value at position 3 by multiplying it by 5. Our loop control variable becomes 4. We go into the loop. And this process continues until our loop control variable becomes 5. And now 5 is no longer less than loop test 1.length, which means we jump out of the for loop and we've completed what we wanted to complete. We've updated each of the elements by multiplying it by 5. Okay. Now let's take a look at the for each loop. Exact same start. Okay. We have an initializer list that's going to create loop test 2. But notice what's different about this one. With this one, the first thing that happens when I hit the for loop is we create an integer variable called value. And value is the actual contents of the element. It's not the index position. Okay, again, remember that for each does not use index positions. So we're going to take the contents of our element. We don't even necessarily know which one it is. We just know that our for each loop is going to give them to us one at a time. And then as we go into our loop, we're going to multiply value by 5. Then we're going to get the next value. And again, we don't know its actual location, but we're taking the contents of an element and storing it to value. And then we're going to multiply value by 5. And then we're going to get the next integer value. And we're going to multiply that one by 5 and the next integer value. So notice as we go, really the only thing we're changing is we're changing this integer variable off to the side that we're using as kind of a temporary placeholder for the value of the element that we're looking at. So this is why it's important to understand that with a for each loop, we can access a value of an element, but we can't actually modify it because there's no way without an index position to know which element we need to change. Okay, so now we get to the point where we get to the last one. We change value to 25. And at this point, there isn't really even a loop control variable that we need to compare to size. All of that's done automatically for us. So we jump out of our for loop and our loop test 2 remains unchanged. The only thing we've ever changed was value. Okay, so here's our check for understanding. I want to know what the outcome is of running this for loop on int values as it's shown. Okay, now if you were with us last week, I think I referred to one of the practice problems or one of the check for understanding problems as an Akbar question. So if you are familiar with Star Wars, you know that General Akbar is the one that always says, it's a trap. This is another one of those Akbar questions. So I'm going to give you about a minute to get into this, but be looking for the trap. Everything is not what it appears. Have you found the trap yet? Okay, we've got about 15 more seconds. Okay, if you think the outcome, or if the outcome you came up with was that this for loop is going to display 63105, raise your hand. Be honest. Okay, put your hand down. We can't see you. Let's walk through what this is actually going to do. Okay, the first thing that's happened, just like we did with our for each loop before, is we're going to create a variable called value. And there's nothing magic about the word value. That's just a variable name. So I just called it value because we're getting the value of the element. Okay, but it's going to take the contents of the element, not the index position, and it's going to store it to value. Okay, then we're going to come down inside the for loop. And the first thing it's going to tell us is that we want to go to int values position value, which value is 6. Our value is not our index position. Our value is the contents, which means if you're really kind of paying attention, what we're really looking for, or what we're telling it that we want it to try and do, is go to int values position 6. Well, there is no int values position 6 because I only have 5 elements in my array, so they're numbered 0 through 4, which means we are going to throw an index out of bounds exception. So hopefully you caught that one. That one was kind of a trick, okay? But the point I wanted to make with this one, because it's a common mistake to make, if we're using a for each loop, we're not getting an index position, okay? I can't stress that enough. For each loops do not use index positions. They give us only the actual value that's in the element, okay? So hopefully everybody got that okay. Let's do our debrief. All right, so I gave us a little table where we could do some comparison for our debrief, okay? Some differences between the two. We'll do a little compare and contrast. A for loop uses an index position, okay? So for for loops, we use index positions. An enhanced for loop does not use index positions. And that's a big difference. It doesn't seem like much, but it is a big difference because The use of index positions gives us the ability to access and modify elements in an array or an array list. In an enhanced for loop, we can only access the elements of an array or an array list. We can't modify. And some people look at this as a pro and a con. I would agree that it's beneficial that we can access and modify. I put a little question mark with the con on this one because I'm not sure you could really call that a con. I think it depends on what it is that your algorithm is trying to do. If our goal is to go through and look at all of the elements in an array and not change them, then is that really a con? Because now I'm guaranteeing that I can't have bounds errors, and I'm really doing what that for each loop was intended to. It's giving me access to each of the elements. Okay. While we're on the topic of bounds errors, the for loop, there is a risk of bounds errors. The enhanced for loop, there is no risk of bounds errors, which is definitely a pro and a con. So each for loop has its own advantages and disadvantages. Which one you choose to use is just going to depend on what it is you're trying to do with the algorithm that you're putting together. Okay, so there is our overview and summary of for each loops and their comparison to regular for loops. All right. All right, Mrs. Westerland, I'm going to turn things back over to you for the rest.
All right. Let me get over here and swap and present. Am I good?
Looks like you're good.
All right. So I loved that. I was taking notes, and now I see from that last slide, I'm going to make a chart. So I'm not going to give them to you all, though, until you have a couple days to do them yourself. So, I'm going to try to wean y'all off a little bit. But so AP exam tip of the day for us is different. It's a little different, and I thought this was important. I think probably because some of my friends are sharing on social media what they're doing at home. And I thought about my own child who takes AP Bio, and he has a desk in his room, and he has his little space that he uses. And I thought about you and what you might have. So I found an article, and there's nothing magical about this article. It was just one, and it was numbered, and it was simplistic, and so I liked it. So here's some things I'd like for y'all to do as an AP tip for the next day or so, because it may not be you can accomplish it today. I want you to think about your needs, what you have, and what you need in terms of a workspace. You're going to have an open notes, open book test. So you're going to need a space that you can spread some things out. You may use one device that day. You may want to use more than one device that day, but you're going to have hopefully some reference material available to you, place to write, a place to get to your devices. Find a zone in your house. You might have a basement, and you could set up a card table there, or, some kind of file cabinet that you turn into a tabletop, or an old kitchen table, and make it your little space. Maybe it's your room, maybe it's a dining room that nobody uses much, and you can, claim that as your AP zone. Utilize what you have. Obviously, we're not going to be going out shopping to bedazzle our workspace. Think about what you need and what you already have available to you. At my house, I've had to commandeer. I had a desk in my sewing room, but it was primarily a sewing room, and sometimes I scrapbook, but I've had to kind of commandeer it and move some things out of the way and make that my workspace. You need to be comfortable, and maybe you're not as comfortable every day when you watch a 45-minute lesson. But the day that you take your AP exam, and I'm assuming that a lot of you are like my students and you're in multiple AP classes, I hope you are, you're going to have multiple times where you're testing in this space for 45 minutes. So you're going to need things near you, a place to have some water, a place to have something to write with, whatever it would be, a chair that's decent and comfortable. If it's cold there or too hot there, think about those kinds of things. And then you want to get it organized so that what you need is handy and at hand. And what I want to do to make it a little bit fun is I want you to take a picture of your workspace and share it on social media. And I had to get a lesson from somebody. I forgot who it was I asked. What all social media uses hashtags, and I know Instagram does. I have a fledgling Instagram account. I use Twitter some. I know they use hashtags. People tell me that TikTok uses hashtags, but I don't think Snapchat does. If Snapchat uses hashtags, use them there too. And if there's a new social media that I have no idea about because I'm 51 years old and I'm clueless, then hashtag it on there too. Um, since it's more than your CSA workspace, let's hashtag it also with my AP workspace, and maybe we'll get other people from other subjects joining us in this community. And I think it's important that we embrace the fact that we're not alone. We may be by ourselves at our house, maybe with our family at our house, but we're all in this together and you're not alone. So that might be fun. I've asked some of my teacher friends. Mr. Schulz and I have been getting some on on Facebook in the teacher group, and then I asked some other teacher friends of mine. So if you look at these hashtags, there are a few things out there, but I'm hoping there'll be a lot more, and you'll show us what you got. So, and it's not a beauty contest. It's just I'm here and I'm working on computer science A or whatever AP subject it is, and I'm in the family. So that's what we want to do. So that's your AP tip. Oh, here's pictures of us. I forgot that I put this here. So you can kind of see mine on the right, Mr. Schulz on the left. And
mine is going to be getting an upgrade soon.
That's right. We're going to be sitting here for a really long time all summer,
Yeah, my little
talking to
card table
teachers
is
too.
already starting to get too small, so I'm upgrading hopefully tonight or tomorrow night.
Yeah. Well, and you can see I've had to like add a little secondary what do you call these things, TV trays over to my right so that I can write on it. But anyway, make your space. And I want y'all to notice, do you see this? Can you see? I don't know where my mouse is. Do you see this little Lego up at the top of my picture frame? I forgot her the other day. So the next time I'm using the document camera, you're going to have to see my Lego computer science girl. So I realized she was up there at some point yesterday. So anyway, all right, let's talk about the power up. Oh, we have a good bit of time. I don't have to feel like I was trying to like talk fast, but let's see. I do not have a clue what JDoodle things these are down here. Are they from today? I don't think they are. I don't know. Um, I have no idea. They are
We might
from
have forgot to
someday.
update the slide.
Yeah, I
Yeah.
don't know. But anyway, the code from today is in the Google Drive, so you'll find it there. But there's some kind of code in JDoodle. So there's the resource page. Here's what I want you doing tonight, and it's going to be a little different. So I'm going to unpack it for you after I kind of tell it to you. First thing I want you to do is go back and think about yesterday's lesson on traversals and make sure that you're comfortable traversing an array from the beginning, like forward in ascending order by index position, and then also in reverse order. So look at that.
Can I jump in again real quick?
Yes, please.
Yeah, yesterday I mentioned that the little analogy to Java programming being kind of like a shop class, like a wood shop class, and array traversal being a tool. This is my personal opinion, but if I had to pick the 5 tools that I would want, if I was limited to the number of tools I could take with me into a test or an exam or into a specific project, array traversal would definitely be in that top 5. So that would be one that you definitely want to make sure you're comfortable with going into this exam. And again, my opinion, but array traversal is one of the most important tools, I think.
Yeah, and if you're
There are
keeping
plenty
a
of others,
tally,
but
it's going to be hard to find a free response question that we'll ever do any day that doesn't have a for loop or a for each loop. I mean, there
yeah.
are some outliers, but you're going to see them in either part A or B or both. If we were keeping a tick mark page.
Yeah.
So good point. Okay, so what I want you to do tonight is different. From the course and exam description, the CED, which on these Powerup PDF pages, I have the CED linked up here under resources. I'm going to show you how I want you to read and analyze the topics for this week. And just pretend that I'm talking to adults and not, teenagers. You're adults, basically. You think you're adults for sure. So I'm going to talk to you like I talk to the teachers maybe in the summer, or if I'm at a workshop with teachers, the course and exam description is written, in my opinion, primarily to the students. It is also for teachers, but you're the learners. We're also learners in the course. And so it's College Board's manual to you about the course that you're taking. There is no teacher answer guide for an AP course. We have the course and exam description that is our guidebook for both the student learner and the teacher facilitator learner. So I'm going to show you how to analyze the topics. Your teachers have probably learned how to do this, and they might have taught you to do it. I teach my kids to do it. I want you to learn to do it because I think there are things to be gleaned there. So I'm going to show you that on the next slide. And then the other thing that is your tip of the day is, of course, to begin to work on your workspace and then share it with us, because I would love to see it. And maybe I'll learn more about Instagram so I can comment back and put a heart or something. Okay, so let me show you what I want you to do. So this is the course and exam description. Like I said, it's linked in the Powerup. I also put it in today's folder in PDF form. You're going to have to go into that document. It's a couple of hundred pages long. And you're going to want to find topics 6.1 through 6.4. Those are the topics that Mr. Schulz and I have been teaching out this week. And the best thing to do is Control F and search for 6.1. And it'll take you a couple of clicks to get through it. And I could tell you the page number, but I don't remember. I have a printout copy near me, but I'll look it up in just a second. I have a screenshot on the next slide. And I'm going to show you there are learning objectives for each topic. There are essential knowledge statements for each topic. And there are many of the essential knowledge statements define something for you. So I want to show you that. And I want you to take notes from these topics. The second thing when you're there is complete the coding traversal and method practice for the arrays that you've created in the last couple of lessons. So on Monday, you made some arrays. We declared some, and hopefully for homework, you declared a Boolean array, a string array, a double array, an int array. Go back and write some code, either using a traditional for loop, mix it up, an enhanced for loop, do some math with one of them, do some if else, if it's true, print it out. If it's not, don't. Work with those. And then the third thing from the course and exam description, I want you to go to page 190, and the page numbers are a little off just because of the way PDFs work. The book page number will always be a few pages less than the PDF page number, but you'll be able to just shoot straight to the PDF page number. Y'all know how to do that in the top right corner. And go to page 197, and that's that little block of the verbs for free response questions. I want you to write those down because you do need to pay attention to what you're supposed to assume, what you're supposed to implement. I forgot what the third, I think there's 4 of them. So you don't have to commit them to memory because you're taking Open Notes tests. So here's a picture, and you can see down there, it's page 112, see down the bottom, of topic 6.1. And remember, you got 4 topics that I want you to look at tonight. So I'm going to show you, this is exactly how I would teach a teacher to learn the metadata of this course or any AP course, because there's a structure to each of these that's similar. So every single topic has an enduring understanding. And what that means is that when it's all said and done and you walk away from Computer Science A after May the 15th, we want you to understand this variable 2. You see it has a little code number in gray. We want you to understand that at a deep level. So that's kind of like the biggest umbrella point for what we're looking to get from this topic. All right, the second thing you'll notice is there's a learning objective, and we call those LOs, I guess, in the little teacher world. And that's always going to be a action verb the student will. Your teachers are familiar with that. And if you're a teacher and you're listening, you're nodding your head. The student will represent collections of related primitive or object reference data using one-dimensional array. So those are always going to start with an action verb, and you are the person that that action verb is directed toward. We want you to be able to do whatever that learning objective says. Then we have this whole little swath of what I like to call column 3, essential knowledge, and that really is the metadata. These are the little bitty points of knowledge. I don't know another word to say it. It could be a vocabulary word. It could be a clarification. You're going to notice in topic 6.4, there's a list of algorithms, and we're going to spend a lot of time on that tomorrow and Friday. So these are, the best word I know is metadata to unpack the learning objective. So in order for you to accomplish the learning objective, you're going to need to accomplish all of the essential knowledge statements. So these are the little, devil in the details kinds of things. All right, the other things that you're going to see on each topic page is one or more, and usually there are two. I probably plural skills. You again are our intended person that's going to be doing these skills. So from this lesson or this topic, you are supposed to, you the student, be able to learn to have the skill of determining code that would be used to interact with program code and write program code to create traverse. So these are the actual action statements that go along with the learning objective that's action oriented, that Mr. Schulz and I are trying to get through to you in each lesson. And then the last thing that you're going to see on this page are links, and they actually are all hyperlinked. So these are the links to the resources that I'm also including in your Power-Ups every day. So it's not that I'm going out and finding those. Thankfully, other wonderful people have done that in the past, and I'm pushing you toward those. And sometimes the topics are a one-page thing. Sometimes they go on to the next page. I think this one continues, and some of them are one-pagers. So I want you to look at topics 6.1 through 6.4 tonight and really spend a lot of time on the learning objectives and the skills and looking at each one of these essential knowledge statements so that you can kind of see, okay, yes, I know how to do that. Think about them like a checkbox. Yes, I know that. Yes, I know that. Yes, I know that thing. That's what we want for you to be able to do. So that's your homework for tonight. And here's a reiteration of what I want you to do. Read them, take some notes, work on your traversals from Monday, and review the verbs. And here are our fun friends for today. I thought this was so cute because both of these dogs are standing up. Isn't that amazing? Bo can't do that. I mean, the physics of the basset hound prohibit, his ears would knock him over, I'm going to say.
JJ can't do that either, and it has
JJ
nothing to do with
can't.
physics.
Okay, well, I think they're so cute. And then I thought Bella was really cute because she let her dress her up. I had a dog when I was little that would let me do all kind of things and pretend like she was a baby. So today, CS Principles has a new release of videos. Tell your friends. And let us know, let College Board know, not me and Mr. Schulz, but let College Board know if you need help with the digital divide. We want you to have everything that you need. And thanks for watching. And I'm
Everybody,
going to be looking for hashtags in the morning. I'm going to get so excited if I see them.
I'm going to
So,
start looking too. I'm excited to see the things you are all putting out there. So
yeah.
Well, everybody have a great day.
Yeah, come back tomorrow. We'll be
Yep.
here.
We'll see
Same
you
time,
then.
same place.